Hello everyone, and today we're going to learn more about average rate of change. It's probably something you've heard about before. Average rate of change is another way we talk about something called slope. So we'll talk about more about that in a second. But for do now here, let's take a look at these two different tables here and try to figure out what type of functions are shown in the tables below. So if we look at this first one, let's see what's happening as x goes up. So x is going up by 1, and g of x, or y, is going up by, let's see, plus 3, plus 3, plus 3. This is a constant rate of change. What happens if something goes up by the same number each time? What type of function is this? This is linear. Okay, but what about this? Here, x is going up by 1 again. On x is 1, you get 24. When x is 2, you get 48. So maybe it's plus 24. But then if you added 24 to 48, you should get 72, but we don't get that. We get 96. So instead of adding 24 each time, what other pattern do we see here? Well, 24 to 48, another way to get there is multiply by 2. 48, is that the same if you multiply by 2? Yeah, it is. 48 times 2 is 96. 96 times 2 is 192. So when x and y, right, what type of function is it when you multiply by the same thing? And we call this exponential. Right, and that's our unit we're working on right now. This is an exponential function. When you multiply by what we call a common ratio, times 2, times 2, times 2. This here is a common difference, plus 3, plus 3, plus 3. Okay, so let's talk about average rate of change. It says a mouse population starts with 2,000 mice and grows at a rate of 5% per year. The number of mice after t years can be modeled by the equation p of t equals 2,000 times 1.05 raised to the t power. So you plug in some t, number of years, and it tells you how many mice there are going to be. It goes up 5% every year. That's just 1.05 because 5% is the increase rate, so 1 plus 0.05 is 1.05. That's what you would multiply by to find out what it is after each year. So it says, what is the average rate of change in the number of mice between the second year and the 5th year? So let's figure out how many there are in the second year. So what we're going to do is we're going to graph this, and we get 2,000, parentheses 1.05, close parentheses, raised to the, we can't put t, so we'll put x. And we graph it. Now I don't see the graph, that's okay. I'm going to click zoom to fit, and there it is. And I want to know for the second year and the 5th year. So again, how do we do that? We get to our table of values. So you click the 3 dots, table of values. Let's go from, we only have to go up to the 5th year. Let's go from 0 to 5. And there we go. So in the second year, there's going to be 2,205 mice in year 2. And then there's going to be 2,552.56 mice in year 5. So how much does it go up on average? Well, let's see. It goes up, what's 2,552.56 minus 2,205? That's how much it goes up. Let's see, 2,252.56 minus 2,205, so it goes up by about 47.56 mice in, well, let's see, year 5 and year 2, that's in 3 years. So how much does it go up on average? 47.56 divided by 3. Sorry, give me 1 sec. Oh, I had a typo. That's why. That's why it didn't make sense. Sorry about that. I had a typo in the calculator. 2552, not 2252. 2552. So it goes up 347.56. Apologies. So if it's 347.56 mice in 3 years, what is that per year? Let's see. Let's do that again. Let's fix that. That's 347.56 divided by 3. 115.85 to the nearest whole number, 116. So what is this rate of change? It's how much something goes up over how much time. That's an average rate of change. Now, it doesn't go up the same every year, but on average, in 3 years, it goes up about 116 mice. So we have our formula here. Average rate of change is the slope between 2 points. And we have a formula here for average rate of change. It says f of b minus f of a over b minus a. And remember, that's our old formula that we knew, y2 minus y1 over x2 minus x1. It's how much has y changed over how much time, right? Change in y over change in x, right? Remember, we might remember change in y over change in x. So let's see some examples of what types of problems we would see. Number 2. Which of the 3 functions has the largest and smallest average rate of change from -2 to 4? So first let's look at g of x, which gives us not a graph, but a table. So from -2 to 4. Okay? So if you think about what this looks like, -2, 0, you don't need to sketch it, but if you thought about what this sketch looked like. So -2, 0, somewhere like here, and then 4, and then 8 somewhere up here, and it says find the slope between those 2 points. So how much has y changed? Y has gone from 0, -8, that's a mistake, somewhere down here. So you want to find the slope between these 2 points. So what has happened to y? Well, if you think about it, you could do the x1, y1, you can name this x, you could do x1, y1, x2, y2, and do the formula y2 minus y1, right? So we get, let's see, for g of x, we get -8 y2 minus y1 over x2 minus x1. And we get -8 over 4 minus -2 is +2, which is 6. And you get that, and you do it in your calculator, and you get -8 divided by 6, -1.333. Right, so that's the rate of change for g of x. I'm going to shrink this down a little. Let's talk about h of x. So h of x we got to look at as a function. This is a good problem because it's going to do it in 3 different ways. So h of x we're going to graph absolute value. Where is absolute value? It is right here of 2x plus 3, and then plus 7 on the outside. And I want to know from -2 to 4 what is happening. So I'm going to do table of values from -2 to 4. So now let's work with h of x. So h of -2 is 8. And h of 4 is 18. Right? So you get, when x is -2, y is 8. When x is 4, y is 18. So we get y2 minus y1 over x2 minus x1. So we get 18 minus 8. Those are what you get. And you get 4 minus -2. So you get 10 over 6. 4 minus -2 is 4 plus 2. And what is 10 over 6? 1.66666. So let's put 1.67, right, approximately. So it's already bigger than g of x. So now we got one more to do. The last one to do is going to be this graphically right here. So when you get -2, you get this point here, which it looks like is -2, -12. And then at 4, you get 4, 0. So we get x1, y1, x2, y2. Always go left to right. So let's do it. Let's do m of x. Let's go full screen here. And we get, same formula, y2 minus y1 over x2 minus x1. So you get 0, minus negative 12 over 4 minus negative 2, which is positive 12 over 6, which is 2. So from greatest to least, the greatest average rate of change is m of x. The smallest is the only negative one, g of x. So greatest, m of x, smallest, g of x, choice 3. Let's try one more. Joelle has a credit card that has a 19.2% annual interest rate compounded monthly, and she owes a total balance of B dollars after M months. Assuming she makes no payments on her account, the table below shows her balance after M months. Well, this kind of sucks. This will show you how credit cards work, guys. If you have $1,000 on a credit card with a 19% interest rate, in 10 months, you now owe $1,172. Look, it happens after 72 months, which is 6 years, $3,000. You owe over triple what you originally borrowed. That's why you always pay your credit cards back quickly. So it says, over which time interval is her average rate of change on her credit card account the greatest? So here, you got to do y2 minus y1 over x2 minus x1 4 different times, right? Your months are your x values, and your balance is your y values. So I'm going to do choice 1 here, okay? From month 10 to month 60, so this is choice 1. So from month 10 to month 60, so we're looking here, and we're looking here. What's the average rate of change between those two values? Well, you get 2591.90 minus 1172 over 60 minus 10. And we enter that into our calculator, and that will give you the average rate of change between months 60 and 10. Let's see what that comes out to. 2591.90 minus $1,172. Take that, put the whole thing in parentheses, guys. So if you just put a closed parentheses, it'll make it parentheses, and divide that by 60 minus 10, which is just 50. And you get an average rate of change of $28 and 0.398 cents, right? So that's your average rate of change between months 10 and 60. Now you're going to replicate this 3 times and find out what is the greatest average rate of change. So you're going to do this 3 more times and find an answer for that. Okay? All right, please don't just copy number 1 and then move on. Check 2, 3, and 4 and find what is the greatest average rate of change. Okay? Let's look at one more, and then I'll let you guys finish the rest. A website is keeping track of the number of views on a newly released math lesson screencast, and they record the total number of views as a function, right? So after how many days, this tells us how many views. Determine the average rate of change in views between day 5 and day 17. So we're looking here and here, okay? Days is x, views is y, so y2 minus y1 over x2 minus x1. That is 920 minus 130 over 17 minus 5. Put this right in the calculator. 920 minus 130, parentheses. Divide that by 17 minus 5. We get, okay, that gives us a fraction. Hit the tool, and it says 65 point, it doesn't say what to round to, so let's just say 60, let's say about 66. Okay, and what does that mean? Okay, and this is important, understanding what that means. It means on average, between days 5 and 17, about 66 people watch the video per day. Okay, so what I'd like you to try is I'd like you to finish number 3, and I'd like you to try, yeah, these aren't that bad because they're only checking 1. Try the rest of the sheet as well, okay? I'll post a key tomorrow. Have a good day, guys.